Right, hello, Lego from the future. So here I will teach you all about the total energy. Okay, so we know that total energy is equal to K plus U, and at the same time it is equal to 1 over 2 m omega square E square, right? Now let's see. So from the graph we know that the rate of change, the rate of change of total energy, which is dt, is equal to 0 because there is no gradient on the graph. That's why it is equal to 0. Okay, there is no gradient, or we call it there is no change of energy with over time. So as the time decreases, the total energy does not change because there is no resistance, which makes that the total energy is conserved. That's what it means. Okay, now let's do some differentiation. So we know that dE total over dt is equal to rate of change of kinetic energy plus with the rate of change of potential energy over dt. Now let's break through. We know that K is equal to 1 over 2 m x single dot square, and U is equal to 1 over 2 m omega square x square. Okay, so us notice that 1 over 2 m is a constant, so we don't want to change. Okay, we don't. What I mean is that this right here constant is cannot be differentiated over time because this constant right here does not change over time. Same as this one, which is here 1 over 2 m omega square right here. This right here is a constant, which means that this is the system here, which is the mass and the angular frequency does not change over time. What makes it what makes it change over time is right here. Right here, x single dot square and x square. So that means we have to differentiate them, these two of these, with the respect of time. So here, which is here, 1 over 2 m, and then times with the d, and then x single dot square over time, right? Because we want to differentiate this with the respect of time, and then plus with the 1 over 2 m omega square times with the d with the respect of differentiation of x square with the respect of time right here. Okay, now let's do some what we call it as the chain rule. Okay, let's go right here. So from the equation, okay, these two equations, since that we want to differentiate with the respect of time, okay, there is no variable of time inside in this equation. Okay, what I mean is that, okay, let's say that we want to differentiate. Let's say that y is equal to x single dot square. So we want to differentiate with the respect of time. So dy over dt, which it means that differentiation of y with respect of t is equal to, there is no t right here. There is no t right here. How do we differentiate it? So we have to use what we call it as the chain rule. We have to use chain rule. So in chain rule, it is say that dy over dt is equal to dy over du times with the du over dt. So I want to do some of the substitution. So let dx square over dt is equal to say this? How do I represent this? dy over dt. Okay, right here. So that means dx single dot square over dt is equal to dx square over du times with the du over dt. Okay, so to differentiate this with respect of u, which means that how do I say this? We want to differentiate this, right? So that means that du is equal to dx single dot, same as this one. This is dx single dot, because we want to differentiate it, right, with respect of x single dot. So what happened that we will get that this dx single dot square is equal to 2x single dot, right? Square is being removed because it's being minus 1, and then 2 will drop down and become a multiplier. Okay, and then times with the dx single dot over dt. So dx single dot over dt right here is actually the rate of change of velocity, which means that it is equal to acceleration, right? Acceleration. So that means it is x single dot. That's what it means, right? So since that we differentiated already, so we do some substitution. So 1 over 2 m times with the 2x single dot times with the x double dot right here, and then plus with the 1 over 2m omega square, okay, times with the dx square over dt. Now we want to differentiate x squared with respect of t. Again, we cannot differentiate it because there is no variable of t inside the equation. So here we have to use another chain rule here. So this is the first, now you have to use the second one. So dy over dt is equal to dx square over dt. Now dx square over dt is equal to dx square over du times with the du over dt. Okay, pretty simple, right? So how do we want to differentiate x square right here? We can differentiate it with respect of x, right? So that means here is equal to dx and here is equal to dx. So that we get that when we differentiate with the x, so we get that 2x, right? Because 2 goes out here and then minus with 1. So 2x times with the dx over dt. So dx over dt is actually rate of change of displacement, which is equal to velocity. So this is x single dot, right? X single dot is velocity, right? Very simple. So we do some substitutions right here. So we get that this one here 1 over 2x single dot times with the 1 over 2m times with the 2x single dot times with the x double dot right here. Okay, and then plus with the 1 over 2m omega square times with the dx square, which is 2x times with the x single dot, okay, is equal to d total energy over dt, which is also equal to 0, right? So here we can cut off here 2 right here, 2 right here. So finally we get that m times with the x single dot times with the x double dot, and then plus with the m omega square times with the x times with the x single dot equal to 0. Okay, pretty simple. Now let's move this one to the right side. So we get the m at single dot times with the x double dot equal to negative m omega square x times with the x single dot right here. Okay, very simple. Can you guys see that? Let's go see, right? Yeah. Okay. So here we want to remove m. So m can be removed here. So we get that x times x single dot times with the x double dot equal to negative omega square x times with the x single dot. And here we can see that x single dot can be removed here. So finally, x double dot is equal to negative omega square x. So this is actually the what you see. We get that the acceleration of the system. So that is all for today, and good luck.